Welcome to True Projects. In this video, we are going to explain about the project, which is a hybrid feature extraction method with machine learning for detecting the presence of network attacks. Introduction of the project. The widespread integration of the internet into various aspects of daily life has ushered in unprecedented connectivity, offering extensive opportunities for business. However, this pervasive connectivity also exposes users and organizations to significant security risks with sensitive information constantly under the threat of unauthorized access and network breaches. The continuous influx of potential trespassers poses a formidable challenge to the network security. Intrusion, the unauthorized access to a system, is a constant concern, and distinguishing attackers based on IP addresses, operating systems, or applications proves to be a challenging task for administrators. Network security measures are crucial to prevent hackers from gaining forbidden access to sensitive information. One prominent technology employed for this purpose is intrusion detection systems, which come in two types, which is signature based and anomaly based. Signature based IDs detect known attacks, while anomaly based IDs identifies unfamiliar assault patterns. Researchers have made the significant strides in addressing security challenges through the incorporation of machine learning techniques in intrusion detection. Machine learning models, including supervised, unsupervised learning, offer diverse approaches in identifying and preventing unauthorized access. The project aims to enhance intrusion detection using a hybrid feature selection approach, leveraging the strengths of different machine learning algorithms. The chosen algorithmic approach addresses the limitations of individual models and strives for improved performance and efficiency. Objective of the project. The primary goal of the project is to create a powerful intrusion detection system specifically designed for network traffic analysis and anomaly detection. The overarching objective is to significantly improve the overall security and privacy of computer networks. The project focuses on the real-time inspection of each packet within the network to identify and detect potential network attacks. This is achieved through the implementation of machine learning techniques enabling a swift and accurate response to a variety of attacks. The project centers on the NSL KDD dataset, a preprocessed version of 1999 KDD Cup dataset. This aim is to extract relevant features from the network traffic data and employ them in training machine learning models. The focus is on classifying, distinguishing normal network behavior from specific type of attacks. An essential objective is to assess the overall performance of the proposed model. This evaluation involves measuring accuracy and error rates, providing insights into how effectively the IDS can analyze network traffic and detect potential intrusions. The project specifically aims to use support vector machine and naive Bayesian machine learning models for both training and testing the dataset. These models are employed to predict the presence of network attacks, showcasing the versatility and effectiveness of chosen machine learning approach in the context of intrusion detection. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Project, we have designed various steps in the flow of work. The first step is importing the packages. This module involves importing necessary Python packages and libraries that are required for the project. We have imported NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for visualization, scikit-learn for machine learning, Flask and SQLite for web development. The next step is exploring the dataset. In this module, NSL-KDD dataset is explored, which is a pre-processed version of original 1999 KDD Cup dataset. The exploration includes examining the structure, features, and summary statistics of the dataset to gain insights into its characteristics. Data processing. This module focuses on preparing the dataset for analysis. It involves converting data to Pandas data frame. In this step, the raw dataset is converted into a Pandas data frame for ease of manipulation. Relevant Pandas functions are employed to read the data into a structured format. Dropping unwanted columns. In this module, unnecessary or irrelevant columns are dropped from the data frame, streamlining the dataset for further analysis. Visualization using Seaborn and Matplotlib. Data visualization is crucial for gaining a deeper understanding of the dataset. This module utilizes Seaborn and Matplotlib to create visual representations such as histograms, scatter plots, and heat maps to explore relationships between variables and identifying patterns in the data. Label encoding using label encoder. Machine learning models often require numerical input, and label encoding is a technique used to convert categorical data into numeric form. This module employs label encoder to transform categorical variables into encoded numerical values. Feature selection. In this step, we focus on identifying retaining the most informative features for subsequent model training. Here we have used two techniques. Recursive feature elimination. Here we iteratively eliminate less important features, optimizing model performance. Lasso, which is least absolute shrinkage and selection operator. It adds penalty term to the objective function, encouraging sparsity in the feature set. The next step is splitting the data into x and y. The dataset is divided into independent variables as x and the target variable as y. X contains the features used for prediction, while y contains the target variable to be predicted. Building the model. In this critical step, the foundational framework for the machine learning model is established. Here we initialize the model with relevant parameters. The objective is to create the structure that will learn from the provided dataset and makes predictions based on patterns and relationships within the data. This step lays the groundwork for subsequent training and evaluation phases. Training and building the model. In this step, machine learning model is trained using the training data. The model learns to recognize patterns and relationships in the provided dataset, adjusting its parameters for optimal performance. Next step is Flask framework with SQLite for sign up and sign in. In this module, a web framework using Flask and SQLite database is established for user interaction. This step includes functionality for user sign up and sign in. The next step is user gives input as feature values. In this step, users are prompted to provide input for the features as user interface is designed to collect feature values. The next step is the given input is pre-processed for prediction. In this module, user provided input is prepared for prediction by applying the same pre-processing steps as the training data. This ensures consistency in the data format. Trained model is used for prediction. In this step, the machine learning model previously trained is employed to make predictions based on the pre-processed user input. The last step, which is final outcome, is displayed through frontend. In this module, the prediction outcome is showcased to the user through the frontend interface. The final prediction is displayed for user interpretation and analysis. Algorithms which are used in this project are support vector machine. It is a powerful supervised machine learning algorithm used for linear or nonlinear classification, regression, and even outlier detection tasks. Though we say regression problems as well, it is best suited for classification. The main objective of the SVM algorithm is to find the optimal hyperplane in an n-dimensional space that can separate the data points in different classes in the feature space. The hyperplane tries that the margin is between the closest points of different classes should be as maximum as possible. The dimension of hyperplane depends upon the number of features. If the number of input features is 2, then the hyperplane is just a line. If the number of input features is 3, then the hyperplane becomes 2D. We have built SVM with chi-square. Chi-square is a statistical test that assesses the independence between categorical variables within a contingency table. It calculates the difference between observed and expected frequencies of the categorical variables and determines whether the observed distribution significantly deviates from what would be expected by a chance. In feature selection, chi-square is often used to identify the most informative features by measuring the dependence between each feature and the target variable. Chi-square feature selection is employed with SVM to enhance the model's performance by selecting the most relevant ones. This helps in focusing on the features that contribute the most to the classification task, potentially improving the SVM's efficiency. We have built SVM with RFE, which is recursive feature elimination. It is a feature selection technique, which is recursive feature elimination, that works by recursively removing the least important features from the dataset. It involves training a model on the full feature set, ranking the features based on their importance, and then eliminating the least significant features. This process is repeated until the desired number of features is reached. RFE is commonly employed to improve the efficiency and interpretability of the machine learning models by focusing on the most informative features. RFE is a feature selection method that iteratively removes the least important ones. Here, we have used RFE with the SVM. This step elimination aids in identifying the most informative features, thereby enhancing SVM's ability to discern normal network behavior from the potential attacks. Coming to SVM with Lasso. Lasso is a regression analysis technique that adds a penalty term to the traditional regression objection function. The penalty term is the absolute value of the magnitude of the coefficients multiplied by a regularization parameter. Lasso encourages sparsity in the model by shrinking less important coefficients to exactly zero. In feature selection, Lasso is used to select a subset of the most relevant features, effectively performing variable selection and improving the model's interpretability. Here, lasso is used for feature selection by adding a penalty term to the SVM's objective function. This encourages sparsity in the feature set, allowing the model to focus on the most influential features with SVM with LASO, which is lasso, is employed to improve the model's interpretability and generalization. The next algorithm is naive Bayes. It is a probabilistic machine learning algorithm based on Bayes' theorem. It assumes that features are independent given the class label, which simplifies the computation of probabilities. Naive Bayes is commonly used for classification tasks, particularly in text classification and spam filtering. We built Naive Bayes using chi-square. Incorporating chi-square feature selection with Naive Bayes helps enhancing the model's performance by focusing on the most relevant features. This combination is effective for extracting informative features from network traffic data, contributing to the accuracy of the Naive Bayes classifier. Naive Bayes using RFE. RFE is applied to naive Bayes to iteratively eliminate less important features, optimizing the model's performance. This step this stepwise feature elimination aids in identifying the most influential features for the naive-Bayes classifier, improving its ability to classify network traffic. Naive-Bayes using Lasso. Lasso is utilized in conjunction with naive-Bayes for feature selection. Adding a penalty term to the objective function, this encourages sparsity in the feature set, allowing the naive-Bayes model to focus on the most important features for effective classification. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built the front end using Flask framework for user testing with user authentication. We have evaluated this project using different performance metrics which are accuracy, precision, recall, and F1 score. Here we have comparison graphs for all those metrics. This is accuracy comparison graph. Here on x-axis we have accuracy score for each algorithm and on y-axis we have algorithm names. Accuracy simply measures how often the classifier correctly predicts. We can define accuracy as a ratio of number of correct predictions and the total number of predictions. This is precision comparison graph. It explains how many of the correctly predicted cases actually turned out to be positive. Precision is useful in the cases where false positive is higher concern than false negatives. This is recall comparison graph. It explains how many of the actual positive cases we were able to predict correctly with our model. Recall is useful metric in cases where false negative is higher concern than false positive. This is F1 score comparison graph. It offers a balanced measure of the model's performance by considering both false positives and false negatives, serving as the harmonic mean of precision and recall. Algorithm which performs well among all these metrics will be used for final prediction. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is NSLKDD train dataset which we have used for training the algorithms. This is the model file which contain algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign-up file. This file is a database file used to store the user information. Now to execute the project, first we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. Here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file and it will execute a Python script and perform runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. This is localhost and this is port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. And this web page is built by using the Flask framework. Here we can see a sign up link. First, we need to click on that. Now we need to enter all the sign up details if you are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password. And now we need to click on login. We have logged in successfully. These are the parameters which are need to be entered. Based on the given parameters, the system will predict whether attack is detected or not. If the attack is detected, it will detect which type of attack it is. Now we will understand all these parameters. So this is protocol type. It is a communication protocol used in the network connection. Here we have service. It is a network service on which the connection is established. Here we have flag. It describes the status of connection indicating conditions like normal or fail. Here we have source bytes. It is the number of data bytes sent from the source to the destination. Here we have destination bytes. It is the number of data bytes received from source to the destination. Here we have count. It is the number of connections to the same destination host in the past 2 seconds. This is SRV count, which means service count. It is the number of connections to the same service on the destination host in the past 2 seconds. Here we have error rate, which is source error rate. It is a percentage of connections with SYN errors. Here we have SRV error rate, which is service source error rate. It is service specific rate of connections with SYN errors. Here we have same SRV rate. It is the same service state. It is a percentage of connections to the same service among the total connections. Here we have different SRV rate, which is different service rate. It is a percentage of connections to different services among the total connections. Here we have DST host SRV count, which is destination host SRV count, which is service count. It is the number of connections to the same service on the destination host. Here we have destination host same service rate. It is a percentage of connections to the same service on the destination host among the total connections. Here we have destination host different SRV rate, which is destination host different service rate. It is a percentage of connections to the different services on the destination host among the total connections. Here we have destination host same source port rate. It is a percentage of connections from the same source port to the same destination host among the total connections. Here we have destination host service different host rate. It is a percentage of connections to the same service but from the different source host among the total connections. Here we have destination host error rate, which is destination host source error rate. It is a percentage of connections with SYN errors on the destination host. Here we have destination host service source error rate, the service specific rate of the connections with SYN errors on the destination host. This is the last parameter, which is destination host REG error rate. It is a percentage of connections with REG errors on the destination host. Now we understood all the parameters. Now we will enter them. So the protocol type is 1, service is 20, flag is 9, SRC bytes are 491, destination bytes are 0, count is 2, SRV count is 2, error rate is 0, SRV's error rate is 0. Same SRV is 1. Different SRV is 0. Destination host SRV count is 25. Destination host same SRV rate is 0.17. Destination host different SRV is 0.03. Destination host same SRC is 0.17. Destination host server different host rate is 0. Destination host error rate is 0. And the destination host SRV error rate is 0. Destination host error rate is 0.05. And now we will click on predict. Based on the given parameters, we got the prediction as there is no attack detected and it is normal. Now we will enter the parameters again but with different values and see what will be predicted. Click on home. I have entered all the parameters. Now we will click on predict. So here we got the prediction as there is an attack detected and the attack type is DDoS. Now we will enter parameters again but with different values. Click on home. I entered all the parameters. Now we will click on predict. So here we got the prediction as there is an attack detected and the attack type is R2L. Now we will enter the other parameters and see what will be predicted. Click on home. I entered all the parameters. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is probe. In this way, if we enter the required parameters to the system, then the system will predict whether attack is detected or not. If the attack is detected, it will detect which type of attack it is. Now click on sign out. Conclusion of the project. The project successfully implemented a hybrid feature extraction method leveraging machine learning techniques to effectively detect network attacks. Utilizing NSL KDD dataset which streamlines data by eliminating redundancy from 1999 KDD Cup dataset, the project created a sustainable foundation for machine learning analysis and anomaly detection. Through meticulous pre-processing and feature selection, the project trained models using a binary classification technique enabling accurate predictions of normal and attack types. Evaluation metrics including accuracy and error rates demonstrated that the enhanced version of the project exceeded initial outcomes. Noteworthy optimizations resulted in improved performance, enhancing the system's ability to predict network attacks. The project underscores the significance of network traffic analysis in fortifying network security against potential attacks. Emphasizing the importance of a robust intrusion detection system, the project advocates for proactive measures to prevent network breaches.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.